Good morning, student. Today we are going to discuss about motion in a straight line. Class 11 Physics, Chapter 3. So first we are getting static, kinematics and dynamics. What is statics? Statics is the branch of physics which deals with the body which is at rest, and the body will be under the effect of forces in equilibrium. That means so many forces act on the body, but net force will be zero. So static is the branch of physics which deals with the body which is at rest, and the body will be under the effect of forces in equilibrium. Okay? Suppose a body is at rest, so many forces acting, but the body remains in its state. This is the static. Now, kinematics. What is kinematics? Kinematics, this is also a branch of physics which deals with the motion of an object without the cause of motion, without explaining the cause of motion. Kinematics is the branch of physics which deals with the motion of an object without explaining the cause of its motion. Why it is moving? No need to explain this. You have to only explain its motion. This is the kinematics. Dynamics, this is also a branch of physics which deals with the motion of an object, explaining the cause of its motion, explaining the cause of its motion. So, what we have got? Static means body at rest, but the body is under the effect of forces in equilibrium. Forces in equilibrium means net force acting on the body is zero. Forces in equilibrium means net force acting on the body is zero. Like this way, suppose this is this marker, and so many forces given in this direction, in this direction, in this direction, in this direction, but the marker is at this position. This is the static, and the forces are called the forces in equilibrium, or it is pulling like this way, like this way, like this way, like this way. If the body remains in its position, then the forces are in equilibrium, and this will be also in static. Kinematics, body will be in motion, but no need to explain the cause of motion. Dynamics, body will be in motion, but you need the cause of motion. Okay? These are the three things. Now we are going to rest and motion. Rest and motion. When you will say a body is at rest, if a body does not change its position with time with respect to its surrounding, if a body do not change its position with respect to the surrounding with time, then this is called the rest. The body is at rest. Suppose it is placed here and it is here. Time is going, it is not moving. So this is the rest. With time, if with respect to surrounding it does not move, that means the body is at rest with respect to the surrounding. And what is motion? If with time the body changes its position with respect to the surrounding, this is in motion. Suppose this is surrounding and it is changing its position with time with respect to this. So this is in motion. And this is surrounding, this is body, but it is not changing its position. This is rest. This is surrounding, this is body, it is moving like this way. That means it is changing its position with time. This is in motion. Now it is said that rest and motion is relative. Rest and motion is relative. Why? Suppose you and your friend are going to one town to another town, or one place to another place by a car. You are sitting side by side. When the car starts to move or starting, then what will happen? Both you and your friend changing position with time with respect to your surrounding. Surrounding means, suppose your residential town. You are changing this position with respect to this town, so both of you are in motion. But your friend, position of your friend is not changing with respect to you with time. So your friend is at rest with respect to you, but both of you and your friend are in motion with respect to your native town. Okay, so due to which it is said that motion and rest is the relative. Once you are telling that he is at rest, another cases you are in the same situation, another cases you are telling that you are in motion. Again I am explaining. Suppose you and your friend are going from Badarpur, a town, to Karimganj, another town. When the car started, then what is happening? You are changing your position with respect to Badarpur. That means you and your friend is changing the position with respect to the Badarpur. So you and your friend both are in motion. But now you see, if we explain like this way, your friend with respect to you is not changing its position with time. So your friend is in rest with respect to you. Just earlier I am telling that you and your friend are in motion. Now I am telling that your friend is at rest with respect to you, and you are also at rest with respect to your friend, because your position is not changing with your friend's position is not changing with you. So both of you are at rest with respect to each other, but both of you are in motion with respect to Badarpur. Okay, so rest and motion is relative. Clear? Now we are going to explain translational motion, rectilinear motion. Rectilinear motion. Rectilinear motion. Another is translational motion. Translational motion. translate rectilinear motion means when a point object or a point moves in straight line, then this is called the rectilinear motion. When a point or point object moves in straight line, then this is called the rectilinear motion. Suppose you are cycling in a straight road. Then it will be considered as the rectilinear motion. Or you are playing a marble. When the marble moves in straight line, we can consider its motion is rectilinear motion. Okay. So when a point or a point mass object moves in straight line, this is called the rectilinear motion. And translatory motion, when a massive body, not point mass object or point object, when a massive body, big body, moves in straight line, then its constituent particles will also move in parallel track in straight line, and each particle will describe equal path. Then this is called the translatory motion. Rectilinear motion means point object moves straight line. Translatory motion means massive object moves straight line. This is the difference. Here we are considering that there is a single point. Okay, and in this case it is considered that the body is consists of so many particles. When the body is moving, all the particles are moving in the parallel straight track, and each particle will cover equal distance. Clear? This is for point object, this is for massive object. Both are moving in the straight line. This is the difference between the rectilinear motion and translatory motion. Both are moving in straight line, but this is point object, this is massive object. Clear? Now circular motion and rotatory motion. Circular motion, rotatory motion. Rotatory. This is also same type. Circular motion means when a point object moves in circular path. When a point object moves in circular path, this is the circular motion. This is the circular motion. Like this, when you draw a circle, the tip of the pencil moves in circular path. So this is a circular motion. This is a circular motion. Or if you tied a stone in a long rope, and if you rotate like this way, then this will be, its motion will be the circular motion. Clear? And rotatory motion means when a massive object moves in circular path, this is the rotatory motion. Massive object moves in circular path, then this is the rotatory motion. Like a fan is rotating, a ceiling fan is rotating, or any fan is rotating, its motion will be the rotatory motion, because its every particle will make concentric circle, and the center of the concentric circle will be lie on the axis of rotation. And with time, each particle will cover equal angular displacement. Okay. This is, in this case, point object moves in circular track. In this case, point object moves in circular track. In this case, massive object moves in circular track. In this case, you are drawing a circle. The tip of the pencil moves in circular path. So this is the example of this. So this is circular motion. And rotatory motion, a fan is rotating. A fan is rotating about its axis. Then it is the rotatory motion, because each and every particle of the fan will cover equal angle in equal time, and each will describe a concentric circle, and the center of the circles will be on the axis of rotation. Okay, so this is also cover circular path. This will also cover circular path, but in case of this is the point object, this is the massive object. In this case, only one circle you will get. Here you will get so many circles, because it consists of so many points, and so every point will cover a circle, describe a circle, and so you will get so many circles, but each circle has a single center. So every point will describe concentric circle whose center lie on the axis of rotation, and every point will describe equal angle in equal time. Clear? Now we are getting vibratory motion and oscillatory motion. And oscillatory motion. Vibratory motion and oscillatory motion. Vibratory motion means when a body vibrates, that means moving to and fro motion, but its amplitude is very small, then this is called the vibratory motion. When a body moves to and fro motion, but its amplitude will be very small, then this is called the vibratory motion, like the vibration of the motion of the tuning fork. Tuning fork, like this. This is the, when it vibrates, its motion will be the vibratory motion. And oscillatory motion, a body moves to and fro or back and forth, but its amplitude will be very large, like the oscillation of simple pendulum, oscillation in swing. These are the oscillatory motion. Vibratory motion means amplitude very small. Oscillatory motion means amplitude is large. Both are to and fro motion. This is also to and fro motion. This is also to and fro motion. But here amplitude is very small. Amplitude is very small. Here amplitude is very large. This, both are to and fro motion. Every case there is a single difference, main single difference. Here motion is point object motion in circular path. Here massive object moves in circular path. Here both are to and fro motion. Both are to and fro motion. But in this case amplitude is very small. In this case amplitude is very large. Here this is the motion of tuning fork. This is the motion of simple pendulum. Okay. Now we are coming to frame of reference. Frame of reference. Frame of reference means to describe the motion of an object, the coordinate system needed attached, and in this coordinate system there will be an observer who will observe the displacement, momentum, acceleration of an object. Then this is called the frame of reference. What is frame of reference? This is the coordinate system attached to an observer. This is the coordinate system like XYZ. This is the coordinate system attached to an observer which will observe the velocity, displacement, acceleration of an object. This coordinate system is called the frame of reference. This is the coordinate system like XYZ attached to an object. That means in this frame of in this coordinate system there will be an observer which will observe the displacement, acceleration, velocity of a moving object. Is called the frame of reference. And frame of reference is of two types: inertial frame non-inertial frame. Inertial frame means the frame of reference which follow the Newton's laws of motion. Newton's laws of motion. This is the frame of reference, a inertial frame. It follow Newton's laws of motion. It follow Newton's laws of motion, and in this frame there is no acceleration. Acceleration equal to 0. And non-inertial frame, this is a frame of reference which do not follow, which do not hold good, in which the Newton's laws of motion do not hold good. That means which do not follow Newton's laws of motion. Newton's laws of motion. Okay, and it has acceleration. In this frame it has acceleration. So what we are getting? Frame of reference means coordinate system attached to a observer which will observe the motion of an object, and in this case he can describe displacement, velocity, acceleration of the object. This is the frame of reference. This frame of reference is of two types: inertial frame, non-inertial frame. Inertial frame means a frame of reference which hold good Newton's law of motion. It has no acceleration. And non-inertial frame of reference means which do not hold good Newton's laws of motion, and it has acceleration. Inertial frame, you see its example like a body moving with uniform velocity. A body moving in a bus which has uniform acceleration. Uniform velocity. A person moving in a bus having uniform velocity, then it is called the uniform velocity means acceleration 0, then it is called the inertial frame. The bus is called the inertial frame. A person moving in a bus moving with uniform velocity, then it is called the inertial frame because it has no acceleration. Non-inertial frame, suppose a person moving in a bus which is moving in circular track, then it has acceleration. Every circular motion is accelerated motion, so it has acceleration. So this is an example of non-inertial frame. Both are here. In this case also the body is in a bus, in this case also the body is in a bus, but here the bus has uniform velocity, that means acceleration 0, and here the bus has acceleration moving in circular path, so there is acceleration. So this is the inertial frame. In this case bus is the inertial frame, in this case bus is the non-inertial frame. Suppose you are in earth, we are in earth, and we are seeing from the earth another object in outside the earth, then this will be the non-inertial frame because earth moves around the sun, so it has acceleration, and from this frame I am seeing another object in the outside the earth. This is the non-inertial frame. Okay. Now, three types of motion: motion in 1 dimension, motion in 2 dimension, motion in 3 dimension. Motion in 1 dimension, 2 dimension and 3 dimension. Motion in 1 dimension, 2 dimension and 3 dimension. Motion in 1 dimension means when a body moves in a straight line. That means to express its motion, only one of the 3 coordinate axis is needed. When a body moves in straight line, then to express its motion, only one axis out of the 3 is required to explain it. This is the one-dimensional motion. That means that motion in straight line is one-dimensional motion because one axis is required. Okay. And two-dimensional motion means to express the motion of an object, we need 2 dimensions out of the 3, 2 axes out of the 3, x, y, z, but you need 2 axes out of the 3. So 2 coordinate axis is required to express the motion of the object. So this is the 2-dimensional motion. For example, motion in plane. Motion in plane. Suppose you are playing carom. So motion of the striker in the carom board, it is a 2-dimensional motion. Crawling of a insect in the wall. This is a 2-dimensional motion. This is sun, earth moves around the sun, so this is in a plane, so this is also 2-dimensional motion. So motion in plane is the 2-dimensional motion. 3-dimensional motion means to express the motion of an object, we need 3 coordinate axes, all the 3 coordinate axes. This is the 3-dimensional motion. That means motion in space, motion of a bird, motion of a bird, motion of a kite in a space. This is the 3-dimensional motion. So 1-dimensional motion means motion in straight line. Motion in straight line. Straight line. Here, how many coordinate axes required? 1 coordinate axis required. one coordinate axis is required. Two-dimensional motion means motion in plane. Here two coordinate axis is required. Two axis are required. And three-dimensional, this is motion in space, motion in plane, motion in straight line. This will be motion in space. Here three coordinate axes are required. So if motion in straight line, this is the one-dimensional motion because one axis is required. Motion in two-dimensional, when motion move in plane, this is the two-dimensional motion. Here two coordinate axis required. Here motion in three-dimensional means motion in space. Here three coordinate axis are required. Example, you are cycling in a straight line. This is the example of one-dimensional motion. You are playing carom board. The motion of the striker in the carom board. This is the two-dimensional motion. Three-dimensional motion example. A bird is flying in the sky. This is the three-dimensional motion. Okay? ठीक से पढ़ना. Only these definitions you require to know. Clear? Bye.